Understanding the network topology and basic setup. From this lecture, you will be able to understand the client-server environment network topology, set up the hostname for each OS and network, configure dynamic routing with Windows and Linux, establishing a tunneling between sites with GRE protocol, encryption of VPN traffic by IPsec protocol. Hello. In the first session, we will allocate IP addresses and hostname to every host. Additionally, we will complete configuring the Site-to-Site VPN for the communication between private networks of HRDKorea.kr and GIFs.net. It takes a lot of time to demonstrate the configuration for every host in network topology. So, I will demonstrate the configuration for only the essential host. First, let's take a look at the configuration of the ISPR host, which is an account for the ISP zone routing. Once the hostname is changed, have the system rebooted. Before allocating an IP address, check alias name for physical network interface. Now, allocate IP addresses to each network interface. Let's check the allocated IP addresses. After routing is finished, activate a policy in Firewall Policies that allows ICMP echo request packets to ISPR for an easier test. Next, we will configure firewall servers for each device. However, I will demonstrate the server configuration of fw.hrdkorea.kr only. Since the hostname of Linux is saved in etc hostname directory, the text tw is added in the file. Of course, configuration with VI or Nano editor is also possible. Basically, the hostname has to be applied in kernel through a system reboot. But to save time, let's apply hostname directly to the kernel variable. The new hostname is applied in kernel, but the hostname will be displayed properly after renewing the terminal. So please log out and log in again. Eliminate unnecessary host information that is created while generating Scratch image. This step is optional. Before allocating an IP address, check the device name for the physical network interface. The link between the server and vSwitch uses IEEE 802.LQ trunking protocol. So, install an additional package to allow a more intuitive Vlan interface name. Once the configuration of the IP address in each network interface is done, restart the network service. Next, let's take a look at the configuration of dc.hrdkorea.kr server, which will serve as the domain controller. Define DNS resolver and write domain suffix list. Now, let's configure the dynamic routing of the public network zone. We will be using the RIP, which is the only routing protocol supported by the Windows Server. To begin with, configure the ISPR router. Install routing-related roles. After the installation of roles, restart the system. Then, install the remote access service only for routing service. Install RIP routing protocol. I couldn't find the PowerShell command for the routing configuration, so I will use netsh, the legacy command. Add network interfaces to join RIP routing. Use RIP version 2, since every networking joining dynamic routing is classless network. Routing information exchange will adopt the multicast. Check routing configuration status. If you wish to use the authentication function for secure routing information exchange, use simple authentication. The RIP protocol provided by the Windows Server does not support the MD5 algorithm. Now, we will configure dynamic routing in two firewall servers. I will demonstrate the configuration of fw.hrdkorea.kr server only. So, refer to the provided solution for the configuration of fw.gifts.net server. Firstly, install packages related to dynamic routing. We will duplicate the sample configuration file and use it. Get rid of enable password for Zebra service access. Change the access password for each service. After rebooting the service, check if the service port is in listen status. remotely log on to the router for RIP routing configuration. After finishing configuring and saving, check the routing table. The communication between private networks of two sites will be connected through the GRE protocol. Again, I will demonstrate configuring fw.hrdkorea.kr server only. Unfortunately, prefix value is unable while deciding the network size for the tunnel zone. Select the encapsulation mode as GRE. For source IP address of the new IP header, I will use the IP address of the ENS 192 interface. Additionally, I will use the IP address of ENS 192 interface of fw.gifs.net server as destination IP address of new IP header. The length of TTL is 8-bit value, so use adequate value. I will use 255. Since the length of the GRE protocol header is a 24-byte value, adjust the MTU value so that IP fragmentation won't happen in the ENS 192 interface. Of course, the MTU value will automatically be set at 1476 bytes, even though this value is omitted. Configure automatic addition of routing table for the communication with gifs.net. Private network after tunnel interface is up. A lot of engineers would add routing table in etc rc local directory, but I recommend my method. Configure automatic deletion of routing table when tunneling interface is down. After configuring, activate the tunnel interface and check the routing table. Install a TCP dump package in fw.hrdkorea.server and check if the communication between the two sites is encapsulated in GRE protocol. To test, send ICMP packet from the dc2.hrdkorea.kr server to mail.hrdkorea.kr server. If you encapsulate the data simply with the GRE protocol, data might not be secure because the contents of GRE encapsulated data is not encrypted. Hence, configure data encryption with the IPsec protocol. Install a package to use IPsec VPN. Defining connection name is up to you. I defined it as GRE over IPsec. We already encapsulated every data with the GRE protocol, so encrypt only the GRE packets. use the pre-shared key method for peer authentication for now. Once the certificate authority is established, we will upgrade it to the RSA SIG method. Use transport mode when encrypting data through ESP protocol in IPsec VPN Phase 2. It is said that the tunnel mode is more secure due to its encryption of the original IP header. However, we already encapsulated the original IP header through the GRE protocol. So even if a hacker exposed the packet, the hacker will not figure out the final destination. Use IKE v1 as key exchange protocol in IPsec VPN Phase 1. You can skip the IPsec proposal set. Configure shared key for peer authentication in IPsec VPN Phase 1. Restart the service and check the service port. And do the same with the fw.gives.net server. Once configuring site-to-site VPN of 2 firewalls, test capturing packets from fw.hrdkorea.kr server to see if actual data is encrypted. Since the communication between 2 sites is encrypted through the ESP protocol, there is no way to figure out the content of ongoing communication. Lastly, you can check the security associations and security policy database with the IPsec status all command.